This is bonding video number 7. By the end of the video, you should be able to determine if a molecule is polar or nonpolar. To do this work, you need your bonding video number 7 worksheet and a pencil. In the past, we have talked about polar bonds. If you had a polar bond, this was caused by an uneven sharing of electrons in the bond, which caused you to have a slightly positive and a slightly negative end to the bond. Now we're going to talk about slight polar molecules. This is similar to the bond in that you'll have a slightly positive and a slightly negative end, but to the molecule. It's caused by having polar bonds in your molecule that are unsymmetrically or asymmetrically arranged. Let's get started. CH4. Based on our rule of is it a polar bond or not, CH4 was a nonpolar bond. So this has a nonpolar bond. It's also symmetrically arranged. It is symmetric because it has no unshared electron pairs on the center atom, and what it's bonded to is exactly the same the whole way around. So, in order to be a polar molecule, you must have both of the following. You need to have at least one polar bond. This one does not. You also must be asymmetric. This one does not. This one is a nonpolar molecule. Okay, second problem. H2O, water. Between the H and the O, this is a polar bond. We have said in the past that if you have two elements that are both nonmetals and they're not the same, with the exception of CH, then this is a polar covalent bond. So we do have a polar covalent bond. First one is a check. Next thing, is it asymmetric? This one is asymmetric. If you have unshared electron pairs on the center, then it is one way to make your molecule asymmetric. Since this one has the polar bond and it is not symmetric, then this is a polar molecule. Okay, let's try some practice on our own. A good best practice would be for you to stop the video and determine if these two are polar or not, and then double check your work. We're going to go ahead and get started with it now. These are our checkpoints. We want to see, does it have at least one polar bond, and is it not symmetric? Let's start with the beginning. NH3. Drawing out your Lewis dot diagram, you get the following. So, does it have at least one polar bond? NH are two nonmetals connected, and they're not the same thing, and they're not C and H. So this is a polar bond. Specifically polar covalent. Next, is it not symmetric? This one has the unshared electron pair on the center, so this one is not symmetric. This is going to be a polar molecule. Let's try the next one. HCN. HCN looks like this. Okay, does it have at least one polar bond? In this case, the CH bond is nonpolar. This is the exception to the rule that if you have two things that are not the same, that they are polar. However, we also have a CN bond. The CN bond is a polar bond. Therefore, we have the first checkpoint. Now we want to see if we're not symmetric. In this case, there are not any unshared electron pairs on the center atom. However, the carbon is not bonded to the same thing on both sides. He has H and N. Since he's bonded to different things, he is not symmetric. Since he has both things, he is a polar molecule. So just to highlight some things, there's two ways that you can be not symmetric. You can have unshared electron pairs on your center, or you could be bonded to more than one type of atom. Also, the polar bond rule. If you have a nonpolar bond, that's okay, as long as you have at least one polar bond. These are the two things that you must have. Both need to be true in order to be a polar molecule.